Have you ever stopped to wonder what's really going on behind the scenes when you use your favorite apps? You know that invisible architecture that somehow keeps everything from crashing down? Well, today, we're going to pull back the curtain and dive into the brilliant and honestly, surprisingly simple ideas that power our entire digital world. But let's start with a question we've all asked, probably while staring at a spinning loading icon. Why do the biggest, most popular apps and websites in the world still crash? I mean, you're using some massive global service, and then boom, it's down. It feels like this shouldn't happen anymore, right? Well, that question gets us right to the heart of one of the biggest challenges in modern tech.
And to really get our heads around both the problem and the solution, we're going to use a little analogy. Let's just call it the one kitchen problem.
So, at the heart of most modern apps is this incredibly powerful system. One of the most popular is called Kubernetes. The easiest way to think about it is like a single, ridiculously high-tech professional kitchen. We're talking automated ovens, robotic chefs, and a system that can juggle thousands of orders all at once.
And this one kitchen? Oh, it is absolutely amazing. It can handle a massive dinner rush, automate the most complicated recipes, and it can even fix itself if, say, one of the stove burners goes out. For serving a single city or a specific region, it is an absolute powerhouse.
But here's the catch, and it's a big one. What happens when your restaurant becomes this global phenomenon? Suddenly, a simple power outage in one city could take out your only kitchen. That single, super powerful kitchen has now become a massive single point of failure.
And that right there brings us to the solution. You see, the smartest companies in the world, they've stopped thinking about just one kitchen. They're thinking in multiple kitchens.
This really lays out the whole trade-off, doesn't it? With a single cluster or a single kitchen, all your risk is in one basket. If it goes down, everything goes down, period. And you're stuck in one location. But when you switch to a multi-cluster approach, you spread that risk out. You can now scale globally, and, this is crucial, you can isolate different jobs. That isolation is so important for security. For instance, you never, ever want your public website to be in the same kitchen as your internal payment system. Separate clusters make that separation rock solid by design.
So, instead of trying to build one giant, fragile super kitchen, the real solution is to build a whole network of specialized, interconnected kitchens all over the world. Now, if one has a problem, the others can just pick up the slack, and your customers never even notice.
But how do you actually organize all these kitchens? I mean, you don't just put them down randomly. Architects use a few really clever strategies to design their global restaurant chain. Let's take a look at the top 3.
Okay, so this table breaks down the 3 core patterns. First up is per region. This is exactly what it sounds like. You put a kitchen in New York, another in Paris, another in Tokyo. This gets food to your local customers way faster. It means a problem in one city doesn't impact anyone else. Then you've got per environment. Now this is cool. Think of it like having your main restaurant kitchen, but also a separate test kitchen out back. That's where your chefs can experiment with crazy new recipes without any risk of, burning down the main restaurant. And finally, per-tenant. This is the VIP treatment. It's like giving a huge client their own private, dedicated kitchen to guarantee security, performance, and total privacy.
At the end of the day, it doesn't matter if you're organizing by region, environment, or tenant. The goal is always the same. As this architect put it, it's about building a system that's resilient, scalable, and secure no matter where your users are. So you've done it. You've built your global network of high-tech kitchens. Awesome. But now you have a brand new problem. How in the world do you get them all to work together?
Let's go back to our analogy. A customer in Paris places an order. How does your system know to send that order to the Paris kitchen? And what if the Paris kitchen needs a special ingredient, but that ingredient is only stored in the warehouse attached to the New York kitchen? That's the communication challenge.
And the solution is basically like creating a universal, super intelligent ordering system that connects all the kitchens. We call it cross-cluster communication. It creates these secure, high-speed pathways between them. It doesn't just route orders to the nearest kitchen. It manages the entire supply chain between them, all automatically, all seamlessly.
All right, we are almost there. We have our kitchens, they can talk to each other. But there is one final, absolutely crucial piece of this puzzle we have to solve: consistency.
So imagine your signature burger is a global sensation. You have to make sure that the burger someone gets in Tokyo tastes exactly the same as the one in New York. How do you guarantee that every single one of your dozens of kitchens is using the exact same, most up-to-date recipe and following the same safety standards?
Well, it's solved with this really clever three-part strategy. First, you create a centralized cookbook, a single source of truth for every single recipe, or what we call a configuration. Second, when you update a recipe, you use an automated system to safely roll out that change to every kitchen at once. And finally, you enforce consistent policies. This means every kitchen, everywhere, must follow the exact same health codes and security rules, no exceptions.
And this, right here, is why all of this matters to you and me. This invisible network of interconnected, consistent, and resilient systems, it's the reason your banking app is secure, even if a whole data center has an outage. It's why your streaming service can handle millions of people watching a season finale without buffering. It's the hidden magic that keeps your online games feeling fast and responsive no matter where in the world you're playing from.
So that's the architecture behind our always-on digital world. And it leaves us with a really fascinating question for the future, right? As our services and devices get even more complex and interconnected, are we eventually going to move towards a future where all these separate clusters start acting as one? Could we see a single planet-wide internet cluster? It's definitely something to think about.